So we're going to see how much of this we can get done. We're going to work on this today, tomorrow, maybe a little bit Thursday. Then I may go back and teach the lesson I skipped on Friday. And then we'll have a few days here to review, maybe do some Canvas stuff, make sure that we're good to go. This is our tentative test day. This could get moved a little bit. I'm not going to tell you for sure that it's going to be the 7th right now because I don't really know how this is going to play out. I'm just kind of winging it and doing as much as I can here. Depends on how well it goes. So let's look at this one. This one says the function f of x equals log of 6x. This is a horizontal dilation because we're multiplying on the inside, right? Inside affects the x's, does the opposite of what you think it should do. So I would call this a horizontal compression, right? It's what's really happening. But the parent function here is g of x equals log of x. Show that f could be written as a vertical translation of g. So I'm wanting to change the form so where it's no longer looking like a horizontal dilation, but looks like g of x plus k. So what is g of x? It tells me here g of x equals log of x. So I need to take this form and I need to rewrite it where it will say log of x. So essentially all those rules that we did yesterday, it's what you're going to work on right here. So what do I have going on? I have multiplication in the argument. I can rewrite that as addition of two logarithms. Now you see how this log of x looks like g of x. Right? And I'm going to write this in the form of g of x plus k. So I'm going to rearrange this to write log of x plus log 6. Can log 6 be considered k?
Yes.
Why? It doesn't look like a constant.
Because log x equals g of x.
Yeah. Plus.
K. Plus k.
Uh-huh. But it says k has to be a constant. What do we think of when we think of a constant? Just some number. Is that just some number?
Yes.
It is. Okay? Does it have any variable in it?
No.
No. But does it look like just some old number? Not the way we're used to it, because it says log in it. But I could go through, what question is this asking? 10 raised to what power is 6? It's some ugly number. I don't want to write it down, but it is just a number. Right? This is not a number because it has a variable. This has no variables in it. So it's just a constant. Okay? So I'm finished. That is what f of x looks like. So we could think of this as my parent function being log of x, and I've shifted the graph up by some number. Right? Up 10 raised to what power 6? 10 to the, it's going to be a negative number, right? But I don't know what. Negative, I don't care. Yeah, I don't care what it is, really, to be honest. So if I have log base b of x, I can rewrite this. I can take any log base I want to. I could take log base a of the argument over log base a of the old base. This is just a tool that you might use. I very rarely use this. Very rarely. Maybe I would say the least important one. I just don't love it. So here, I've got f is log base 4 of x, and g is log base 9 of x. Show that f is just a vertical dilation of g by finding some value k so that f becomes equal to k times g. All right, so this is the statement. I'm probably going to do a bad job explaining this. But again, I've never seen a problem like this, so I would not get too caught up in this. So basically what this is saying is I want to take f and I want to change what it looks like. I want to take f and make it be k times log base 9 of x. So I'm going to take what used to be log base 4 of x and I want to rewrite it with a base of 9. So I'm taking f log base 4 of x. How could I rewrite this with a base of 9 from what we just saw with the change of base formula? Log base 9 of x over is we okay with that? Let's just straight up using that formula. Now, look at the denominator. The denominator is just a number, right? Just like we talked about before. So, I can rewrite this. Let me, okay, this is going to confuse you because fractions confuse everyone. So, let me go here. What is 6 divided by 3? It's 2. Is everybody okay with that? I could rewrite this as 6 times 1/3. What's 6 times 1/3? Do you agree those are the same thing? So I took what used to be in the denominator and I moved it out front and made it a fraction. Same thing I'm going to do right here. I'm just going to do it with log base 9 of 4. If I take that denominator out, it's just a number. I can move it out front and make it be 1 over log base 9 of 4. So we okay with that? Times log base 9 of x. And so what have I done? Log base 9 of x, this is g of x, right? So have I wrote this as g of x times some constant k? I have. That's all it wants us to do. That we remembered, if I have a log with a base of e, like this, log base e, we can write that shorthanded as ln of x. ln stands for the natural log. Okay? So just a reminder of that. We've already talked about that. I want to look at these, and I want to know which of these can I write to look exactly like 3 natural log of x minus 4 natural log of y. Okay, I heard C. What's happening with C currently? We are subtracting the arguments. All right? What can I do when I'm subtracting the arguments? Do we have a rule?
Can't you put if it's raised to a power, you put it out in front when you rewrite it?
If the whole argument is raised to a power, you can do that. This whole argument is not raised to a power. We have parts of the argument are being raised to powers, but the whole thing's not raised to a power.
It's subtraction.
And it's subtraction in the argument. Do we have a rule about subtraction in the argument?
Yeah, it's A.
We don't have a rule for subtraction in the argument.
I thought that was division.
We have a rule for division in the argument. If it's dividing in the argument, we can write it as subtraction of logs. But we have no rule for subtraction in the argument. Okay? Doesn't exist for us. So C, I'm stuck. I have no way to simplify C. Okay? Now if I look at A, what's happening with A? I have division in the argument. Now what can I do if there is division in the argument? I can write that as subtraction of the logs.
Yes. And then you can put...
And now, Correct. Because the whole argument is being raised to the third power, then I can move the 3 out front. So this becomes 3 natural log of x. And then same story on the next one. That's 4 natural log of y. So did that match?
Yes.
It does match. Again, D, I look at D, I can't do anything with that. That's subtraction of the argument. B, I could rewrite a little bit. Right, this is the natural log of 3x minus the natural log of 4y. And then I could keep going because what do I have here? I have multiplication in my arguments. So I could write this as the natural log of 3 plus the natural log of x minus the natural log of 4 minus the natural log of y. You okay with that being a minus? Not really?
I thought it should be a plus.
Yeah, okay. So let's go this way. Let's pretend like this is negative 1 times the natural log of 4y. So this is negative 1 times the natural log of 4 plus the natural log of y. You follow me there? And now if I distribute this negative back out, it becomes negative natural log of 4 minus natural log of y. An easy way to remember it is what? Anything that's being added goes in the numerator of the argument. Anything that's being subtracted goes in the denominator of the argument. I need 4 and y both in the denominator. So they both need to be subtracted. Okay? That's an easier way to remember that. So it's not B. Or if I look at number 1, solve for x, write out each step. So if we had to solve problem 1, what's the first thing you would do? I agree. 5x squared minus 3x squared is negative 9 plus 4, negative 5 equals 27. What are you going to do next? I like it. So that leaves me with 2x squared equals 32. Next. Divide by 2. So now I've got x squared equals 16. Sorry, no, I'm working all over the page here. Now take a square root. And that would give me x equals, I chose to take a square root. Anytime I choose to take a square root, I always have to account for the plus or minus possibility. Have I said that? Maybe. I don't know. Maybe not. I'm like a robot. I say the same crap over and over. So I'm going to say I've taken a square root this year by now. I'm going to say I've said it at least once. I say stuff for no reason. I don't just say stuff for no reason. I'll fix that. Now you've got no proof. If I look at 2, 2 says fill in the question marks. 3 raised to the question mark is 81. What's the question mark?
4.
Okay. 3 to the 4th is 81.
4 negative, hey, plus or minus 4. Never mind.
It's not plus or minus 4. Next, B.
0.
0. 1. It is 1. What question is this asking?
Wait, so
17 raised to 0 equals 1.
This is saying 17 to the 0 power equals the question mark. If you need help, maybe we could rewrite this from logarithmic to exponential. If you rewrite this, this says 17 to the 0 equals question mark. And then what is 17 to the 0? 1, because anything to the 0 power is 1. Well, almost anything to the 0 power equals 1. I say that every time. That's the only thing that's not 1, but you know. C. Log base 36 of what equals 1/2? So again, if I need to solve this, the thing I'm looking for is in the argument. So, like, you know, we had all these steps. Let's tie it together now. We had all of these steps that we used to do when we solved equations. You know how to undo things to get x by itself. Essentially, here's my x. Right? This is my unknown. Whenever the unknown is stuck in the argument, we rewrite it into exponential form. So this would look like what? 36 raised to the 1/2 power equals question mark. And now what is 36 to the 1/2 power? What's another way we can write 1/2 power?
0.5.
Okay, yes. That's not the one that we need to know, though. Half powers can be written as square roots. Remember, it's radical 2, with radical with a root of 2. So this is the square root of 36. What is the square root of 36?
6.
Not plus or minus? It's not plus or minus. I didn't create that square root. So it's understood to be the principal square root. Okay? And now when I look at D, D says 4 raised to what power equals 27? So let's tie this back together. We could do this one in our heads,
Yes.
right? Essentially, 3 raised to what power is 81? But say we couldn't do it in our heads. The thing we were looking for was stuck in an exponent. So how do I get variables out of exponents? We could rewrite this as logarithmic. What would that look like? This would be log base 3 of 81 equals question mark. I'm doing A. And so, again, what does this question ask? 3 raised to what power is 81? This is still 4, right? So we know how to simplify that without a calculator. So what happens when we ask questions like we did on D that are like 4 raised to what is 27? I don't know. I don't get a clue. But I could solve for the thing I'm looking for by rewriting it as a logarithmic equation. So this becomes log base 4 of 27 equals the thing I'm looking for. Now, do you have a calculator on this problem or do you not?
Maybe.
Maybe. If you don't have a calculator, that's your answer. That's a fine final answer. Does it have any variables? Does it have any unknowns? No, that's just a number. It's an ugly number, so I'm just going to leave it in this form. Just like we don't like writing 5/7 as a decimal, right? Because it's an ugly decimal. So we just leave it as 5/7. We don't want to write log base 4 of 27 as a decimal, unless they make me. So I could leave it like this.
Will it be said if we have to write it as a decimal?
Well, you'll know if you got a calculator or not, right? If they give you this problem on one that you don't have a calculator, this is the answer, and I'm done. If you do have a calculator, we know how to type this in our calculator, correct? Okay. We're going to look at 5. So 5 says, what if the question mark is slightly more buried? And it says, think back to question 1 and try to isolate our question mark. So, look, you're close to being grown-ups. Maybe you don't act like it. I'm going to go ahead and write an X there. Are you okay with that? I'll write 4. Some of you act like it. Let's don't get it carried away.
Can we just take 4 and put it on the other side?
Yes. So now that I'm going through all the process of solving for X. So all of those rules for a logarithm, I cannot do them unless the logarithm is isolated. So is this logarithm isolated currently? No, because the minus 4. So I can get rid of a minus 4 by adding 4. So this becomes log base 3 of x equals 9. And so what's this asking? 3 to the power 9 equals x. Do we have our calculator? Maybe not. If we don't, that's what I'm writing. I'm not doing that. Okay? That's awful. Give a V.
Oh, big number.
Is it 720? It's got to be bigger than that. It's got to be bigger than that.
19,000.
Yeah, never mind. Yeah, just ignore me. It's what, 19,000?
Yeah.
Okay. So next, what do I have? If I rewrite this, this is 5 times 2 to the 7 minus x equals 40.
Divide by 5 on both sides.
Very good. So that gives me 2 to the 7 minus x equals 8.
We can write that as 2 separate. 2 to the 7th and then.
I'm thinking of 2 different ways we could solve this from right here. So there's 2 ways you could go. Tell me what you're thinking. I'll go your route first.
2 to the rewrite it as 2 to the 7th minus 2 to the 8th. Is it 2? Is that right? Or no, it's times 2 to the negative.
Okay. That was not one of my 2 options I was thinking, but that's fine. There's nothing wrong with this. Then what would you need to do? I'll tell you in a second. You gotta stick to a path until you completely are stuck. So I would divide by 2 to the 7th next.
Yes. 2 to the negative x equals
8 over 2 to the 7th.
a small number.
Well, okay, so yeah, let me go this route here. Can I rewrite 8 as a power of 2? This is 2 to the 3rd over 2 to the 7th. Is 8 the same thing as 2 to the 3rd? And so now then, what is 2 to the 3rd divided by 2 to the 7th?
2 to the negative 4. So x equals 4.
So because I now have the same base, I can drop the bases and say negative x equals negative 4. That's an option. Okay.
Is there a simpler option?
I don't know. Simpler is a strange way to think about it. Here's what I was thinking. My first thought was very similar in the way it's going to end. Right here, I saw I could write 8 as 2 to the 3rd. So I would write this as 2 to the 7 minus x equals 2 to the 3rd. And now what do I have? Now I have the same base, so the exponents have to be equal. And so then from here, if I move that over, it becomes positive. Move that over, it becomes negative. And so it has a similar ending. Maybe that math's a little bit easier than having to do what we did before. Or, if you're a logarithmic purist, what you could do right here is, my exponent is stuck in my variable is stuck in the exponent. How do I get variables out of exponents? I rewrite it as logarithmic. So I could rewrite this because the power is isolated. This is log base 2 of 8 equals 7 minus x. What is log base 2 of 8? What's this asking? 2 raised to what power is 8? You see I'm at the same junction. Is one of these correct? No, they're all correct. It doesn't matter which way you go. You just have to come up with something that follows the rules, that uses those steps that we talked about, that can get you to the final answer. Okay? There's way more than one way to solve every one of these. Are these the only 3? Probably not. Because I didn't think of this at all until Ken just told me, go this route. But it was fine if you stick with it. That's what I'm telling you. If you show your work and you get there, there's multiple ways to go. Like I was branched out to these 2, and Cam showed a 3rd. So am I saying these are the only 3? Probably not. There's probably 4. No. But these tools that you've added for logarithms, they have to just be like any tools that you would use to solve equations. You just use them when it's time to use them. All right, let's look at C. C is the natural log of the square root. I'm going to change that to x. Is everybody okay with that? X minus 8 equals 0. Thoughts?
Okay, so
You get rid of the square root.
I do not like a square root as my argument. I'm not a fan. So what could I do instead of writing square root of x minus 8?
square both sides.
Nope. You can't square both sides because that square root is in the argument. If it was the square root of all of this, then you could square both sides. All right, you see the difference? That square root's in the argument. I'm not allowed to just square both sides and get rid of it.
You can't even square 0.
You can write it as
Can't, it's 0.
over 2.
That's correct. That's the route to go. Square root in the argument can be written as raising the argument to the 1/2 power. Now what? I have an exponent in the argument. I can write that as multiplying out front. Now what? Is the logarithm isolated? No. It's being multiplied by 1/2. So how can I get rid of multiplying by 1/2?
Times by 2.
Times by 2, divide by 1/2. Same thing. These cancel. What is 0 times 2? 0. Do I have my logarithm isolated? Yes. I have no exponents. I have no number out front. I have no ugly radical anymore. So what would be the next step I'd want to do? My variable is stuck in the argument. So let's switch this from logarithmic to exponential. What's the base of a natural log? E. So I could write this as e raised to the 0 equals x minus 8. What is e raised to the 0? Yeah. Anything to the 0 is 1. Well, almost anything to the 0 equals 1. Now, can I solve?
8, 6, 9.
That's so pretty. Like, I hate teaching all the logarithmic stuff, but I love this part of it. Like, this is so much fun. But trying to explain why and how, it's not so great. I'm going to try something else, okay? Because just like we saw before, there are multiple ways to do this. I'm not entirely sure this is allowed. It is allowed. I think it'll work. If from here, like I don't like that radical, but let's just say I could leave it. What would happen if I rewrote it right now into exponential form? This would be e to the, what's e to the 0? What's next? What's 1 squared?
Oh my gosh, it worked. I love when it all equals 0, then you can just do whatever you want. So. Like literally.
Now, the only things that we need to talk about right now, and then we'll probably wrap up. Remember, when we start doing these, what is required? What is required? So if this is in the form of log base A of B, A has to be greater than 0. And so because of that, B also has to be greater than 0. So anytime we solve and find a value, we always have to plug it in to make sure it doesn't give an illegal answer. So like right here, my x was in the argument. It was the only thing in the argument. So what is 3 to the 9th power? It's something positive, right? So does that make that negative? It doesn't. Here, what did we find? We found x was equal to 4. If you plug 4 back into the original, 4 minus 7 is that 7? I can't see.
Yeah. 3.
4 minus 7, or 7 minus 4, sorry. 7 minus 4 is 3. Are we okay with this exponent being 3? No problems there. And then here we found 9. What if I plug 9 in here? 9 minus 8 is 1. The square root of 1 is 1. And so the argument is 1. Is that allowed? That's fine. I would just say e raised to the 0 power is 1. Right? And that worked just fine. So what I'm telling you is anytime you solve for an unknown in a logarithmic equation, you have to plug it back in to make sure it doesn't give an illegal, ineligible answer. Okay. Now look at 6a. 6a says, if I take 4, what power do I need to raise it to so that it's equal to 4 raised to the 11th power?
11.
Is that groundbreaking stuff?
Yes.
So what did we learn here? If I have the same base on each side of an equation, I can just drop the base and set the exponents equal to each other. Right? That's what they wanted you to learn right there.
I just
Yes.
looked at it.
Yes. That'll work too. For this one. So the next one, I have 5 raised to the 3x minus 1 must equal 5 to the 20th. So now using that same rule, what can I do? I can drop the bases. 3x minus 1 equals 20, which means 3x equals 21, which means x equals 7.
This thing rocks.
Everybody good with that? C, what do I see?
Wait.
Log base 4 of some number must equal log base 4 of 10. Luckily, I have a whole box of pencils just for people like you. That's PBS programming. I don't know if they still do that. They did when I was a kid. They would say for people like you on PBS programming. I guess not. You guys don't watch PBS, I guess.
Like PBS Kids?
Yeah.
Yeah. Used to watch it.
Okay.
Wow, crap.
I don't have a clue what the Wildcrats is. We watched what's the guy's name?
Computer lab.
He's a mouse. He's a rat. No, not Mickey Mouse.
Wait, what'd you say?
It's some mouse or rat. I think he's a rat mouse looking thing.
It wasn't great.
It was on PBS. No. All right, let's just keep going. If I look at C, log base 4 of x equals log base 4 of 10. What does x have to equal? So what could I do here? So here's the rule on this one. When I have a single logarithm on both sides that has the same base, I can drop that logarithm. But only when it's a single logarithm. So when you look at D, you see how D is log base 7 of 20 equals log base 7 of something. Can I drop all of these logarithms? I can't drop them yet because it's not a single logarithm. But can I rewrite this as a single logarithm? Subtraction of logs can be rewritten as division of the arguments. Now, do I have a single logarithm on both sides? Drop the log base 7. So 20 equals x over 2. Thank you.
I saw it. I sniffed it out without even doing anything.
On the last two, what do we have to make sure we do? After we've solved a logarithmic equation, plug it back in to make sure it does not make the argument negative. Does 10 make the argument negative? No. Would 40 make this argument negative?
No.
So we're good. They both work. Okay, so we haven't had any issues yet, but I promise they're coming. I've got the natural log of x plus 8 minus the natural log of x equals the natural log of x. Thoughts?
That's kind of sense.
And probably,
That means
probably
x is 0, right? No.
Thoughts? I need to work on simplifying this.
Alright, so x, would it be x squared, n?
Natural log,
Natural
ln.
x squared plus 6.
No.
X plus 6 over 8.
Yes.
Wait, I got this. X equals 6. Already, I know it.
I have subtraction of the logarithms. Subtraction of the logarithms can be rewritten as division of the arguments.
Did I know it? Did I not know
Now what?
Well, we know that
The x's cancel.
We know that x plus 6 is double natural log of x.
I have a single natural log on both sides of my equation, which means I can drop the natural logs. And so x plus 6 over x must equal x.
So, the x over x equals 1. So 1 times 6 is 6.
That's some bad math if I've ever heard it. On the left side, I have a fraction equal to a number. Anytime I have a fraction equal to a number, I always make this a fraction equal to a fraction. Because what can I do when I have a proportion?
Can't you just
I can cross multiply and set them equal.
swap the x's on the first one and
Yes.
get 6 equals x?
I still know what you're talking about. No. Yes, I do know what you're talking about. No. You're saying this.
No.
You're saying this cancels to give you 6.
Yes.
No. Bad. Wrong.
But it does.
Stop.
Wait, why can't it not do that?
Okay. Let's put a real number in here. Okay. Let's put the number 3. I don't know why I picked 3. So what is this? What's 3 plus 6? 9. What's 9 divided by 3? So you say the answer should be 3, But according to your math, I can just drop these and it's a 6. Right? That's what you're telling me to do.
Oh, so
I can't do that. What you can do, because it's a monomial, you could write this as x over x plus 6 over x. X over x is 1 plus 6 over x. But does that make you feel any better about where we're at? Not particularly.
no.
Right?
But I know the answer's 6. That's why I was trying to do that.
It's not 6. So,
The answer's
it's not 6. So, can I get back to what I was doing? Is that okay? It's not 6. Back to here. I have a fraction equal to a fraction. So I can cross multiply. What is x times x? What is x plus 6 times 1? I set them equal to each other. Now what do I have? I have a degree 2 for x, and I have another x. So how can I solve when I have two different x's raised to different degrees? Well, I'm going to get everything to the same side.
Oh, you say you got a binomial.
It's not a binomial. It's a quadratic or a trinomial. There's 3 terms there.
Oh, so you got to factor.
So I'm going to have to factor this. So A times C method if you need to, or we could factor this by sight. This should be x minus 3 times x plus 2.
So it's negative 2 in the positive.
Let's calm down. Let's slow our roll. Let's slow our roll. So 2 things multiply to be 0. This means either the first thing is 0 or the second thing is 0. So x could equal 3 or x could equal negative 2.
But it can't be both.
It could be. Or it could be neither. What do I have to do once I solve a logarithmic equation?
Check it out.
I have to plug them in to make sure it does not make the argument become negative. So let's plug in 3 for all of these x's. Would that make any of the arguments become negative? 3 plus 6 is 9. That's okay. Natural log of 3, that's okay. Natural log of 3, that's okay. So 3 works. Now I also need to do the same thing with negative 2. Let's plug it in. Does this make any of the arguments negative? It does. It makes the last 2 both negative. So because this makes the argument negative, it cannot be a solution. So the only valid solution is x equals 3. That, my friends, is a logarithmic equation. All right, can you guys try these 3?
No, not Disney.
Try these 3 on your own.
No.
All right, you should be finished with the first one. So if you're not finished with the first one, let's talk about that.
Okay.
What should we do on the first one? It's a logarithmic equation. The variable is stuck in the argument. So how can I get it out of the argument? Rewrite it as an exponential. So what is this in exponential form? 49 to the 1/2 equals x. What is 49 to the 1/2 power? That's the same thing as the square root of 49, which is,
Oh, savant.
or just 7.
That would be my guess, but I was not going to guess because I figured out that doesn't get you a good grade.
It will not.
It gets you all right.
What questions do we have about that? All right, that should be a 10-second problem. A should be. And I'm finished with B now.
Log base 6 of 36 equals x, right? You rewrite it as that.
You could.
You understood 6 to the x equals 36, and then.
I mean, I got that first.
Again, different ways we could go. Obviously, we need to get rid of this 10. Is everybody on board with that? 6 to the x equals 36. Now, there's 2 very correct routes we could go here. I heard one say rewrite this as logarithmic. That would be log base 6 of 36 equals x.
I wrote it in both.
And what is log base 6 of 36?
6. Or 2 squared.
Remember, what question is that asking? 6 raised to what power is 36? 2. Another way you could have done this without a logarithm, if I have 6 to the x equals 36, let's rewrite both with a base of 6. 36 could be rewritten as 6 squared. Then what could I do? I could drop the 6's, so x equals, I don't care which one you choose. You need to know both.
That was so much better. Because you don't have those letters in there.
You could just look. I mean, this one you can just look at it and know the answer.
Sounds good.
It's 36 times 36.
Very few can just look at it and know the answer, but sounds good.
On that one?
I mean,
That one's not too bad. Look, if you guys get stuck in only being able to look at it and do it, when the exponents get uglier and when the bases get uglier, you're not going to be able to do these steps. You have to know one of these two ways. I promise. Or it's going to get too difficult, like the last one you saw, where it was all variables. Okay? Let's look at C. C says 5 plus e to the x plus 1 equals 20. Subtract 5. So e to the x plus 1 equals 15.
And then you can rewrite it as e to the x times e to the 1, right?
Yes, but I would not recommend that.
We know the answer. We know what e to the 1 is. It's e.
Yeah.
And e is a number.
well, we're not using it like an exponent, are we?
Is e?
Just wait. I'll entertain your way in a second. I'm not going to go down your rabbit hole because I think it's going to confuse people. It's going to confuse me. What would I do from here? My variable is stuck in an exponent. How can I get it out of the exponent?
By doing what you just said.
I could rewrite it into logarithmic form. This becomes log base e of 5 equals 15. Sorry.
Equals x plus 1.
Log base e of 15 equals x plus 1. What's another way I can write log base e?
Natural
Log
log.
ln.
The natural log of 15 equals x plus 1. And now is x by itself? No, because we're adding 1. How can I get rid of adding 1?
Subtract 1 on the other side.
So what is the natural log of 15 minus 1?
Probably natural log of 14.
It's not.
We can plug it into our calculator, right?
We could, but let's just don't use a calculator. Let's just say the natural log of 15 minus 1 is the natural log of 15 minus 1.
Oh, it's already simplified?
I like that. I really like that, honestly.
Okay. All right, let's look at these. Question A. First, we've got the natural log of 2x minus 2 equals the natural log of 11.
X equals 6.5.
Okay.
You get rid of the loggers.
So because I have a natural log, a single natural log on both sides, I can drop the natural logs. That leaves me with 2x minus 2 equals 11.
Add 2 on both sides. 2x equals 13. Divided by 2 equals 6.5.
And what do I have to do now? I have to make sure that this does not make any argument negative. So if I plug in 6.5 here, 2 times 6.5 is 13. 13 minus 2 is 11. So we're good.
11 equals 11. Oh, the next one.
That's what I would do.
What?
I would try to rewrite them both with the same base. So I can rewrite 8 as
2 to the third.
2 to the third.
2 to the x squared minus 6. What?
And so what can I do now that they both have a base of
Drop the base.
2?
You want the 9.
I don't know what you're saying. I can drop the bases and I can set the exponents equal to each other.
We need x squared minus 6 equals.
Add 6 on both sides. Take the square root of both sides.
Oh, dude, I was trying to get 9.
X squared equals 9.
Yeah, exactly.
What's the square root of 9? Kind of.
Trade.
Because I chose to take the square root, so I have to account for the plus or minus possibility. If I plug in positive 3, is that okay? Yeah, they're not arguments of a logarithm, right? They're exponents. So exponents can be positive or negative. So both of these are valid. Positive 3 and negative 3.
I didn't choose to take the square root,
But then you'd be stuck here.
but then I'm forced.
That's correct. If you're forced to, you may change it. If you're forced to take the square root of both sides,
Yeah.
that's fine. What I'm saying is the problem didn't start with a square root. If it started this way, then it's only 3.
But you did it.
But I chose, or I was forced to take a square root of both sides. Here we go. We're looking at
I got 4x to the third.
again. It's just chaos that's going on. What's the first thing I need to do when I look at
Put
this?
2 over x.
No.
X is squared.
Yeah.
I need to move the 2 to be an exponent. That has to be first.
I mean, I say we should move log 4x to the other side first.
No, that's a terrible idea. If you move it to the other side, then you're going to have a 1 over there still.
We can get rid of that 1.
By.
Dividing by 1.
That doesn't get rid of 1.
Minusing 1.
So if you subtract 1, then it's on the left side.
You gotta get rid of it, so you gotta.
So whenever I have some terms that have logarithms and some that don't, I want everything that has a logarithm on one side.
Rewrite it.
I don't want to rewrite it. Everything that has a logarithm is already on one side. So y'all just chill. Just chill. Thanks. Now what do I have? I have 2 logarithms with no numbers in front of them that are being subtracted. I can rewrite subtraction of 2 logarithms as division of the arguments.
Why wouldn't you drop the logs to make it?
Because it's not a single logarithm on both sides.
Oh.
There's 2 different logarithms on the same side. And this is that whole discussion we were having with them. They were telling me, move the other logarithm over. But I still don't have a single logarithm on both sides because of this 1. So then they told me, well, then just get rid of the 1 by subtracting 1. Well, then what's going to happen? Well, now the 1's over here. I still don't have a single logarithm on both sides. So that's not going to work. I have to get all my logarithms on one side, which they already were when that happens. So now what do I have? I have a single logarithm. I can actually simplify this. Do you guys know what x squared over x cubed is? X over x squared, which will simplify again. When you're multiplying powers, what do you do to the exponents? Well, if this was x to the second times x to the third, what would you get? You add the exponents.
Well, you're dividing, you subtract.
That's correct. When you divide them, you subtract. So this would be x to the first. For me, we had x squared over x cubed, which should be what? X to the negative first. 2 minus 3 is negative 1. And what is x to the negative first?
1 over x.
1 over x to the first. So for me, the way I would do this one is I always take whichever side has the larger exponent, and I'll just subtract 3 minus 2, and I know that that power goes wherever the larger exponent is.
And so is that.
Right? So I don't have to go x to the negative 1, then move
Is
to the
that
bottom.
simplified all the way?
Not yet, I don't have x by itself. I mean, the argument is simplified, but x is still not by itself. So I need to rewrite this from logarithmic to exponential, which would give me 4 to the first equals 1 over x. What is 4 to the first?
4.
So for me, the right side, the x is stuck in the denominator. So I would write the other side over 1, make this a fraction equal to a fraction, and
1/4 equals x.
cross multiply.
No.
So 4x equals 1. Divide by 4, so x must equal 1/4. Is this for sure our answer? Well, not yet. What do I have to do to ensure that this works? I need to plug 1/4 in to make sure it doesn't make any of my arguments negative.
How is that not on the spot?
It does not make them negative. They will be positive. So 1/4 is good. This says use your graphing calculator. Well, I'm going to do this without a graphing calculator because I don't like using my graphing calculator. I could solve this without a graphing calculator. So let's just trust our steps. What would I need to do in order to isolate the x?
Divide by 6.
I like that first.
But that's going to give us a social decimal.
So let's just leave it as a fraction.
So we get e to the first.
No, don't do that. It's a bad strategy. You keep doing that, that's a bad strategy.
Alright, so we got.
Technically,
It works. I'm not going to teach that strategy. You can keep doing it that way, but I'm never going to show it again. Okay, this is an exponential. I'm going to rewrite it as logarithmic. This is log base e. I can write that as
25/6.
the natural log of
25/6.
25 over 6 equals.
1 minus x.
And so now what would be required to get x by itself? Well, I'm going to move it over to this side, which would make it positive. We okay with that? And I'm going to move this to the other side, which would make it negative. Is x by itself? Solved.
Booyah. Ln to the 25 negative 75 negative.
1 minus ln.
So now let's see what this number is, and then I'll show you how they wanted you to solve this. Okay? So if I do 1 minus the natural log of fraction 25 over 6, I get negative 0.4271163,556. Everybody
Wait,
gotten there? Done that?
I gotta find my calculator.
Mine's, yeah.
I don't really care what that is. So like on Canvas, if it asks me for the answer, I would just type this in as my answer. Right? Don't do anything else, just type that in.
Would that also work?
You have to write all those decimals out, but just leave it. Why would you write all those decimals out?
Where's
I
natural?
know.
Where's natural
Side
log?
by side 4.
Oh, right here.
Again, when I type that in, I get negative 0.427.
I got, whoa.
Negative 0.427. Everybody's good with that? Now, they wanted us to solve it not algebraically like we did. They wanted us to solve this graphically. So let me show you what they want. These are two different graphs. Like I could graph this, I could graph this. Where would I see that they were equal? Where are two graphs equal? Well, wherever they intersect. That's where they are equal to each other. So we're going to click y equals. We're going to type this into the first one, which is 6 times e raised to the 1 minus x. And then in the second one, I'm just going to type in 25. That's correct.
What are you using a capital?
Nope.
No,
It's underneath. It's the natural log. You see e to the x?
Mm-hmm. Yes, sir.
Sorry. I forgot to talk about that. I'm going zoom 6. With zoom 6, I cannot see where they intersect though. Right? I can just see one of my graphs. Why can I not see where they intersect? Well, because I know this one is y equals 25. That's a horizontal line at 25. So I need to go change my window. I'm going to make the y max 30. Now I can clearly see where they intersect. Everybody on
What's
board?
the Y min?
I've left everything else the same.
Wait.
All I changed was the y max to 30. Because
I don't know what my Y min and stuff is all messed up.
so click zoom and 6. Like go back to your main menu, click zoom and 6 to get a 10 by 10 or 20 by 20.
And then change.
Then just change the y max to 30.
Okay. Now how do I get your
Hit graph.
graph?
Graph.
That I didn't put the thing in. Like I don't. I missed the
Y
step.
equals.
Oh, Y equals and then you put
Okay,
it
type those two equations in.
top. 1 minus the 1 minus
6 times e to the 1 minus x.
6
Natural law.
Above the natural log.
That's natural law.
e to the 1 minus x.
How can I find where these two intersect? Like I see the intersection. How can I find exactly the point of intersection? Second calc, right? Above the trace. Number 5 is intersect. So I can just choose where these two graphs intersect with each other. It tells me negative 0.427.
That's
The same thing I got algebraically. This is how you could solve it graphically. Anybody in?
I got 0.4545. How do I do that? How do I see where they intersect?
It was negative point.
You gotta choose your curves so that you're good. You gotta
see where they intersect. I need to look.
make the same curve. So see, first one's on the red line, second one needs to be on the blue line, and then guess if it doesn't matter.
Oh, first curve.
So you gotta use, I don't know, somehow you got on the same curve. If you switch your graphs, you click up or down to switch to the other curve. If get
What'd
the-
you click? Calc intersect?
Yeah.
Rob?
We good with this?
Wait, which one did you click for this?
Here I'm given a function and I'm asked to find its inverse. So this will be a big review for us because we skipped all the inverse stuff. Because I taught you how to find inverses in Unit 2 with Northeast, right? So let's find the inverse here. How do we find inverses? Simply stated, we exchange the x and the y. So first things first, I'm going to rewrite this. Instead of saying f of x, I'm going to say y equals 3 raised to the 4x minus 1, minus 5. Then we exchange the x and the y. Right? Right? That's the process of finding inverses. We change the x and the y. And now to solve it, we've got to get y by itself. So let's go through this process together. What am I going to do to get y by itself? Add 5 is step 1. So now x plus 5 equals 3 raised to the 4y minus 1.
By 3.
Divide. Divide is not going to help me. Because if you divide this by 3, what are you left with?
4 y2.
No.
4 over 3.
Yeah, no, you're left with
Ugliness. Okay? That division does not get rid of a base. How do we get rid of bases? That's the new math we're learning now. Got to rewrite this as a logarithmic equation. So this would be what? Log base
3
of
x plus 5
equals
4 y minus 1.
X plus 5.
We good with that step? That's how we get rid of a variable in the exponent. We have to write it as a logarithmic equation. Now what? Get y by itself. Add 1. So I've got 4y equals, what's that ugly log plus 1?
The ugly log plus 1.
That's correct. That ugly log plus 1 is that ugly log plus 1. The 1 does not go inside the argument. It can't break in. It's separate. And now what? Y is being multiplied by 4. So y equals that.
Oh, then you just put it all over 4.
That's what I would do.
Then you erase the 4.
With chem math, we could say this is a base of 3 plus 1 is 4 over 4. Those cancel. No, you can't do that.
I don't like that way.
I do like my way because